In a piston pump, the liquid is displaced by the shoemaker. In the cycle of operation of such a pump, two stages can be distinguished. Discharge, when liquid is displaced from the pump, and suction, when liquid enters the working chamber. During the discharge phase, the pump will be at its maximum flow, and at the suction phase, there will be no flow. That is, when the piston pump is operating, high flow pulsations will be observed. This is an undesirable phenomenon, since the smooth operation of the actuators of the hydraulic drive at high pulsations cannot be ensured. Simply put, the hydraulic cylinders will move in jerks, which will cause vibration of the entire installation. A press machine or a hoisting machine. In order to reduce pulsations, several pumping units with pistons can be installed on one drive shaft. If the rotation of the shaft is perpendicular to the axis of the working bodies, or makes an angle with them more than 45 degrees, then such a pump is called a radial piston pump. If the axis of rotation of the shaft is parallel to the axis of the working bodies, or makes an angle with them less than 45 degrees, then such a pump is called an axial piston pump. That is, an axial piston pump is a rotary piston pump, in which the axis of rotation of the drive shaft is parallel to the axis of the working bodies, or makes an angle with them less than 45 degrees. In order to ensure the linear movement of the pistons during the rotation of the shaft, it is necessary to tilt the cylinder block relative to the axis of rotation, or tilt the washer on which the pistons rest. In the first case, the pumps will be referred to as axial piston with a swash plate. In the second, with a swash plate. Let's try to figure out how these pumps work. Displacers in axial piston machines can be pistons or plungers. Pumps with plungers are sometimes called axial plunger, but often this feature of the names does not reflect and is called an axial piston pump regardless of whether the displacer is a piston or plunger. In axial piston pumps with an inclined unit, the axis of the working bodies is at an angle to the axis of the drive shaft. This angle determines the magnitude of the piston stroke. Its value is less than 45 degrees. In most designs, the tilt angle is 20 to 30 degrees. When the rotor shaft rotates, or the cylinder block is also driven through the pistons pivotally mounted on the drive shaft. The rotor is pressed against the spherical surface of the distributor disc on which two crescent-shaped grooves are made. As the drive shaft rotates, each of the pistons moves in the rotor bores. The amount of movement depends on the tilt angle of the block. When the piston moves to increase the volume of the working chamber, liquid is sucked in through the sickle-shaped groove and fills the chamber. When the piston moves in the opposite direction, the volume of the working chamber decreases. The fluid is displaced through another crescent groove. Hole and goalkeepers in which move. The pistons are evenly distributed, while some pistons displace fluid, others move in the opposite direction. This ensures a continuous supply of working fluid by the pump, with significantly reduced pulsations. In swash plate axial piston pumps, the axes of the working bodies are parallel to the axis of the drive shaft. The movement of the pistons, or plungers inside the rotor, is ensured by the swash plate, on which the plungers are supported through the pusher. The rotor is fixed on the shaft with a key. Therefore, when the drive shaft rotates, the rotor rotates, and with it the plungers. The plunger, when the drive shaft rotates, it moves in the rotor holes. When the working chamber increases, the liquid fills it. When the plunger moves in the opposite direction, liquid is forced into the discharge line. Variable axial pumps. As mentioned earlier, the stroke of the pistons depends on the angle of inclination of the block, or washer. It turns out that, if you change this angle, then you can change the volume of the working chamber of the pump, and therefore adjust its flow. Pumps, the design of which provides for a change in the volume of the working chamber, are called adjustable. Variable swash block and swash plate pumps are available. In the design shown, the swash plate is acted upon by a spring on one side and a control plunger on the other. With an increase in pressure under the plunger, the angle of inclination of the disc will decrease, the pump flow will decrease. In Theshian variable axial piston pump with an inclined unit, a helical gear is installed which allows you to change the angle of inclination of the block and therefore change the displacement and flow of the pump. If the pump converts mechanical energy into the energy of a fluid flow, then the hydraulic motor performs the opposite functions, converts the energy of the fluid flow into mechanical energy, that is, the fluid flow in the hydraulic motor makes the shaft rotate. Many axial piston units are reversible, that is, they can perform the functions of both a hydraulic motor and a pump. Consider the operation of a swash plate hydraulic motor. Oil from the pressure line through the sickle-shaped groove enters the working chambers. The liquid forces the plunger to move. The axial force developed by the pistons is transmitted to the washer. Due to its inclination, a tangential force arises which causes the rotor to rotate. The torque is transmitted through the key to the shaft. With further rotation, the liquid is displaced by the plunger into the outlet line. Rotation at this moment is provided by other plungers. Compared to other hydraulic machines, axial piston units have the Bistavral and weight characteristics, good speed and high efficiency, up to 95–99%. Most of the structures are designed to operate at a pressure of 2135 MPa. There are special versions of machines operating at pressures up to 55 MPa. Compared to radial piston machines, axial piston machines are faster. The rotational speed of the shafts of typical machines is 2000–4000 RPM. Special versions can operate at a frequency of up to 30,000 RPM. These advantages determine the widespread use of axial piston machines in hydraulic drives of machine tools, presses, aircraft, road building machines, and special equipment. Don't forget to be a member of the tech searching team. See you next time. Thank you.